So we know that there are different types of quadratics and that the different types of quadratics can depend on the types of roots that they have. So let's have a look at how they look visually first of all. So we have the situation where we have two real roots. So the quadratic passes through the x-axis in two different locations. We've got the situation where we've got one real repeating root where it has the x-axis as a tangent. And then we've got the situation over here that we've encountered before where the quadratic has no real roots. Now, we've only ever dealt with this as kind of a case that we couldn't solve. But now that we're into complex numbers, we're going to be able to actually work towards a solution for the roots of this type of quadratic, because although it doesn't have any real roots, it does have complex roots. And just take a moment for yourself to see, can you remember the three statements that we had for how we could determine what type of quadratic each of the situations represented? So you can see here that in the scenario of two real roots, we've got b squared minus 4ac. In the scenario of one real root, we've got b squared minus 4ac equals to 0. And then if you've got complex roots, that is going to be less than 0. And of course, that's the portion of your minus b formula that's underneath the root in any case. So if you've got something under the root that is less than 0, then clearly you're going to have to be employing imaginary numbers and complex numbers in your solution. So here's our question. We're going to solve x squared plus 4x plus 5 equals to 0. And I'll tell you in advance that this particular quadratic is going to have complex roots. So here's our formula, and we're going to identify our values for a, b, and c. So a is going to be 1, b is going to be 4, and c is going to be 5. And then we're going to substitute those into the formula. So again, if you want to take a moment here at the stage to pause the video, do that yourself, and then unpause at the stage at which you run into difficulties. So I've substituted in my values at this stage. So I've got my a, b, and c substituted in, and I'm going to begin to solve out my values. So I've got minus 4 plus or minus the square root of, now when I put in 4 squared minus 4 times 1 times 5, I'm going to end up coming out with the root of minus 4. Okay, so if I was in a normal scenario at this stage with a quadratic, back in the algebra chapter, I'd say to myself, okay, right, I've run into a problem here. I can't solve this out. I don't have any possible solution for root of minus 4. Okay, I'll just categorize this as a quadratic that doesn't have any real roots. But now that we're looking at complex numbers, we're actually developing the skills to cope with this. So as we've seen previously, if we have the root of a negative number, we can actually write that in terms of I. And that's pretty straightforward by just splitting up the root minus 4 so that we've got the factors of minus 4. So we're going to proceed on that basis. So we've got x equals to minus 4 plus or minus the square root of, 4 times minus 1 all over 2. And I know, of course, now that whenever I've got a minus 1 under a root, I isn't far behind. So I'm going to split up that root into root 4 and root minus 1 all over 2. And then, of course, I can evaluate root 4 and I can replace the root minus 1. So I'm going to have x equals to minus 4 plus or minus 2i over 2. And then I simply want to just divide both parts, the real part and the imaginary part, by 2. So I've got x equals to minus 2 plus or minus 1i. And if you like, you can write this separately as two distinct roots, and that will be x equals minus 2 plus 1i and x equals minus 2 minus 1i. In this particular question, I've solved my quadratic with a variable of x. But what you'll actually find a lot of the time is that when you're dealing with complex numbers and you've got a quadratic, that they'll generally tend to call the variable z. And that z is kind of a reference back, if you like, to the z's that we were calling complex numbers previously, z1, z2, z3. And z tends to represent a complex variable.